Yes friends, welcome once again to the class, and we will start with lecture number 2 of chemistry optional UPSC. GOC is going on. Okay, so let's see. Now, definition of inductive effect. You have already learnt what is inductive effect in the previous class. Now we will learn about definition of inductive effect. Inductive effect may be defined as a permanent displacement of sigma bond pair electrons due to dipole or a polar bond. So it is a permanent displacement of sigma bond pair electrons. It is a permanent effect. Please note that it is a permanent effect. Okay, a permanent displacement of sigma bond pair electrons due to a dipole or a polar bond. Okay, so it is a permanent effect. For example, one chlorobutane you had seen. Okay, one chlorobutane you had seen, meth, eth, prop, but. Okay, you had seen. So it was a permanent displacement of sigma bond pair. The CCl sigma bond which was there, it was permanently displaced towards this chlorine. Okay, so the electron now the thing is that the orbitals have not left completely their orbitals. Okay, the electrons have not left their orbital completely. The partial negative charge just means that there is a slight displacement of the sigma bond pair towards chlorine. It does not mean that the carbon has completely donated its electron to the chlorine atom. It is not like that. Okay, so we are going to learn that. Important points about inductive effect are like this: that polarization of one bond is caused by polarization of adjacent bond. Okay, you can see over here that due to polarization of this bond, this particular bond, due to polarization of this particular bond, as the electron cloud spends more time around chlorine as compared to carbon, around which it is spending less time. It is spending less time around carbon and more time around chlorine. Okay, so there is a slight shift. Okay, now there is delta positive charge on the first carbon atom, delta positive charge on the second carbon atom, delta positive on the third carbon atom, and from the fourth carbon atom onwards the effect is negligible. Okay, so due to the polarization of this particular bond, due to polarization of this particular bond, delta positive charge has been acquired by this carbon. So this delta positive of this carbon in turn polarizes this bond. Okay, so this is also this carbon is also polarized. So then this carbon is polarized, so it will try to attract the electron cloud towards itself. So this bond will also be polarized because of this bond, and this bond was polarized because of this bond. Okay, and this process continues, but from fourth carbon onwards the polarization is so feeble. From the fourth carbon onwards the polarization is so feeble that we cannot experience it at all. Okay, it is almost negligible, we can say. So from fourth carbon onwards it is almost negligible. Okay, so this is the thing which you must remember. Okay, this is the thing you must remember. So polarization of one bond is caused by polarization of adjacent bond, as already told to you. Okay, polarization of one bond is caused by polarization of adjacent bond. It is also called as transmission effect. Okay, it causes permanent polarization in molecule, hence it is a permanent effect. This is the point to be noted, my lord. Okay, permanent polarization in the molecule, it is not a temporary effect. We will learn about other effects also which are temporary in nature, but this particular effect is not temporary, it is a permanent effect. Inductive effect is a permanent effect, you must keep this in mind. Okay, then the displacement of electron takes place due to difference in electronegativity of the two atoms involved in the covalent bond. Okay, why does the displacement of electron take place? Because due to the electronegativity difference of the two atoms involved in the covalent bond. For example, carbon and chlorine. So there was electronegativity difference between carbon and chlorine. Chlorine was more electronegative and carbon was less electronegative. Chlorine was more electronegative and carbon was less electronegative. So the electron sigma electron pair, please remember that pi electron pairs are not displaced. Okay, pi electron pair do not show inductive effect, only sigma electron pair show the inductive effect. Okay, what are pi bonds? Pi bonds are, if suppose there is a CC triple bond. Okay, let me show it to you. What are pi bonds? It is going to come later, but for the time being understand it like this. Okay, this is going to be the sigma bond, and these two are going to be the pi bonds in C triple bond C. In C triple bond C, one bond is sigma and two others are pi in C triple bond C. Okay, so these pi bonds will not show inductive effect, only this sigma bond will show the inductive effect. This is the thing which you must keep in mind. The displacement of electron takes place due to difference in electronegativity of the two atoms involved in covalent bond. The electrons never leave their original atomic orbital. Okay, for example, over here in one chlorobutane, there was sp3, this carbon was sp3 hybridized. Okay, this was also sp3 hybridized, and this was also sp3 hybridized, and there was one chlorine also. Okay, so the thing is that there is p orbital of chlorine, right? P orbital of chlorine. So p orbital of chlorine overlaps. P orbital of chlorine overlaps with sp3 orbital of carbon to give a bond, but this bond undergoes polarization due to inductive effect. But please remember this thing, that the delta positive charge which is occurring on carbon and delta negative which is occurring on chlorine, these are just because of slight shift of electron cloud towards chlorine. It does not mean that the carbon sp3 electron has completely left its position and has gone over to p orbital. It is not like that. Okay, it is not like sp3 hybrid orbital has an electron, and that electron has completely left the sp3 hybridized orbital and has now completely gone into the 3p orbital of chlorine. It is not like that. Okay, you must remember this thing. The electron is still paired up. The electrons are still shared. Not paired up. The electrons are still shared, but the electron spends more time around the chlorine nucleus. The electron spends more time around the chlorine nucleus and lesser time around the carbon nucleus. Electron is spending more time around chlorine nucleus and less time around carbon nucleus. So this is the fact you must remember. Okay, its magnitude. So that is the thing. The electrons never leave their original atomic orbital. Its magnitude decreases with distance. It is almost negligible after third carbon atom. I already told this to you, that its magnitude keeps on decreasing. In one chlorobutane, what happened? After the third carbon atom, the fourth carbon atom was there. So on that fourth carbon atom, there was no effect of this inductive effect. It did not acquire any delta positive charge. Okay, the fourth carbon was almost unaffected by this effect, because the magnitude keeps on decreasing as we move away from the substituent. Okay, for example in one chlorobutane, as we move away from this chlorine, as we move towards the carbon away from this chlorine, so this is a carbon which is away from the chlorine, very much away. So over here there will be inductive effect. Over here on this first carbon it will be most prominent. On this first carbon it will be most prominent. On second carbon it will be less prominent as compared to first carbon. Then on the third carbon it will be even less prominent than the second carbon. Okay, and as soon as we reach the fourth carbon, it is not prominent at all. Okay, it is not prominent at all. So the prominency of this inductive effect, that is the effect of this inductive effect, is visible only till the third carbon in the chain. Okay, so most prominent on first, lesser prominent on second, even lesser prominent on third, and on fourth almost negligible. Okay, so such is the situation. So if you haven't watched the first lecture, you must watch it, I think. Okay, some of you might not have watched the first lecture. So the magnitude decreases with distance and it is almost negligible after third carbon atom. The inductive effect is always operative through sigma bond. This also I told you. Inductive effect is always operative only through sigma bond. Never, it does not involve pi bond. Okay, through sigma bond only it does not involve pi bond electron. Pi bond electron is not involved in inductive effect. For example, suppose we have a condition situation of this kind. What is this? This is dichloroethane, right? Dichloroethane. So in this dichloroethane, what happens? In this dichloroethane, the inductive effect will be on this due to this chlorine. There will be inductive effect on this, and due to this chlorine, the inductive effect on this will be lesser. Okay, so delta positive on this one, this first carbon, and delta positive on this second carbon. Then due to this chlorine, let me show it with red. Delta positive on this carbon, as this is number 1 for it, number 2 for it. So delta positive on this carbon. Okay, and so these have become more positively charged. Delta, because delta plus delta equal to plus delta. Okay, so it is a more delta, means more positive charge has occurred. Okay, because the inductive effect of 2 chlorine is acting. But remember that only this sigma bond will undergo, only these sigma bonds will undergo the inductive effect. Okay, these two pi bonds, this pi bond and this pi bond will not show any inductive effect. Okay, so in the pi electrons over here, and here will spend equal time around the carbons. They will spend equal time around the carbons. They will not be displaced towards any particular nucleus. Okay, so that's the thing, that thing you must remember, that inductive effect is always operated through sigma bond. It does not involve pi bond electron. Similarly, suppose we have a situation of this kind. Okay, so this oxygen shows delta negative charge, carbon shows delta positive charge. Okay, because oxygen also shows minus I effect, means oxygen also attracts the electron cloud towards itself. So minus I effect is shown by oxygen also. So only this bond, only this sigma bond will show that minus I effect. Okay, this particular bond which I am highlighting with red color, now let me highlight with blue color. This particular bond, blue is suppose your pi bond. So this pi bond will not show any inductive effect. Okay, only this is the sigma bond. Suppose this color represents the sigma bond. Suppose, so only this sigma bond will undergo inductive effect. Okay, this blue colored pi bond will not undergo any inductive effect. So the pi bond between oxygen and carbon, will spend the electron cloud of pi bond. The electron cloud of pi bond will spend equal time with oxygen also and carbon also, but the electron cloud of this sigma bond will spend more time with oxygen and lesser time with carbon. Okay, so sigma bond will spend lesser time with carbon, more time with oxygen. It will be displaced also towards the O, but the pi bond, which is blue in color, it will spend equal time with carbon and oxygen both. So inductive effect is always operative through sigma bond, does not involve pi bond electron. Okay, so this is the thing you must remember. So thank you very much. Someone was asking whether such small videos can lead you towards completing the course. Yes, the course will be completed. I don't know how much time it will require, but the course will be completed for sure. Even if it requires 3 years, suppose it requires me to complete the lectures. suppose the complete course is completed in 3 years, so I will keep on uploading till 3 years. You don't have to worry for it. Okay, so thank you very much.